Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cece.
I'm Braxton. For math homework help, call in Bakersfield 636-4357. Everywhere else, it's 1-866-636-6284. Our email is dothemath@kern.org. We are online at dothemathonline.net and on social media.
All right, thank you, Braxton, for taking care of that. Where do you attend school?
I attend Frontier High School.
And what year are you in?
I'm a senior currently.
So school's out
Yep.
pretty soon.
Yep, one more quarter and it's
All right.
all over.
Yeah, I know. I was going to say, I think this is the beginning of the fourth quarter right now, isn't it?
Yeah, it just happened. The end of third quarter was on Friday.
Okay.
So
Plans yet for when you're through with high school?
Right now I'm kind of leaning towards either Bakersfield College or the Air Force. So
Okay.
yeah.
You could do both, I guess.
I mean, I could, but you know, it's just either save money while in college and then go transfer to a 4-year,
Right.
or go to the military, do 4 years, and then just have my kid set up with the GI Bill.
So if you did that way, why the Air Force as opposed to one of the other branches?
The Air Force, because the Marines is, for lack of better words, for like people that like to just rah.
Okay.
No, they're very out there. So the Air Force is good because I've wanted to pursue mechanical engineering or aerospace engineering. And
Okay,
if I
so
join the Air
you've
Force,
explored those opportunities and careers in that branch.
Yeah.
Okay. Now, you were here a number of years ago.
Yeah.
And have you ever heard the saying that when you look into somebody's eyes, you can see their soul or know a little bit more about the person?
Yeah, I think I've heard something like that before.
Okay. Because if I'm not mistaken, the last time you were here, that's all we could see of each other.
Yeah.
You remember that?
Yeah.
Right?
Half my face was covered because of
Yeah,
the mask.
by all of us, right? We all, so you know what? Check this out. And in studio with us, we have Braxton. And Braxton, if somebody wanted to get a hold of us, what would they need to do?
For math homework, call help in Bakersfield 636-4357. Toll free 1-866-636-6284.
So it's going to be $360 plus $72 more dollars.
Yes.
What would that mean that our new debt is?
It would be
We're at 6 tens and 7 tens. We're adding those two together. So 6 plus 7.
yes. I did it wrong.
I don't know what I'm
Circles matter.
Circles matter.
Brings back memories, huh?
Yeah, it does.
For us as well, right? I mean, we were right there with you and stuff like that. So nice to see that you have returned.
Yeah.
Right? And you're ready for whatever math that we give you today.
Whatever
right?
one, yep.
All right, good. Well, you know what? First of all, we're going to take care of today's social media problem of the day.
Okay.
So the both of us are going to take a look at it. We're going to work it out in our head. Together, here we go. So simplify 9 to the 7th power divided by 9 to the 5th power. So are you familiar with exponents and their rules of how you would solve something like this?
Yes, I am. Yes, I am.
Okay, so what do you think we need to do here?
So the answer is D. It's both B and C, because when you go with the division, the rules of the exponents is because it's 9 to the power of 7 over 9 to the power of 5.
Right.
You're going to do 7 minus 5.
Good.
And then that becomes 9 to the power of 2, or 9 squared, or 81.
Right. So explain a little bit 9 to the power of 2, 9 squared, and why that's 81 instead of 18. Because there will be some kids watching right now, and they'll go 9 to the second. Why is that not 18?
So 9 squared it's a difference between 9 times 2. 9 squared, it's going to be a smaller 2 on the top corner, as you can see. The 9 to the power of 7 So if you take the 9 to the power of 7 minus the 5, you get the 2. And then you'd get 9 times 9.
Right,
So the
so you
difference,
take that base number.
yes, the base number times itself because it's the 2. But if you were to have 9 to the power of 7, you do 9 times 9 times 9 7 times.
Right, and that's going to be a big number.
Yeah,
and there are
that'd
some
be
kids that may look at that and go, all right, I do 9 7 times,
Yeah.
and then divide it by the number that I get when I do 9 5 times, and that's just more work.
That's just way more work. You don't need to do all that. You can just do the 9 to the power of 7 minus 9 to the power of 5 equals 9 to the power of 2.
Which is why you need to know those laws.
Yes.
All right, nicely done. So that is today's social media problem of the day. And you think it is D, B, and C, so there you go. First one done, all done. Don't
go.
say that wasn't that hard, was it?
Nope.
All right.
1 for 1. Let's see.
636-4357 is that phone number. We do have phone tutors available Tuesdays and Wednesdays throughout most of the school year. Today, you are on a big day. Did you know that?
I didn't.
Today is the final day of live broadcasting for Do the Math for our 23rd season. 23 years. Can you imagine that? You're not
That's
even that old
crazy.
yet.
Nope.
So we've been going quite a long time. So we'll be back again in September of next season for our 24th season. But all throughout the spring and summer, you'll be able to check us out on social media. We'll have a lot of things going on. And Do the Math will always be being rebroadcast during rebroadcast. I said that, rebroadcast. I can say rebroadcast too. So I make up all sorts of words, Mac. Anyway, that's what we have to deal with. when you get people back there like that.
Yeah.
Anyway, you understand what I'm saying?
Yeah.
All right, good. Time now for today's Math in the News. All right, today's Math in the News has to do with an event that just happened down in Los Angeles. It was the Los Angeles Marathon, and there was history made at the LA Marathon. And you can see a photo of 2 people right here. The first American to win first place since 1994. This guy did it. He came in first place, and it's a big deal because there are people that come from around the world to race in these marathons. And a lot of times they are dominant, and they dominate marathons a lot. And the LA Marathon has not been won by an American since 1994, so that was a big deal. But even bigger than that, I think, is the next one. A Bakersfield native, this lady came in 3rd place, and she's going to be running the Bakersfield Marathon also. Savannah. She won 3rd place, and she's a Bakersfield native. And the reason I bring that up is because the Bakersfield Marathon is going to be coming up, and that is coming up on March 30th. So if you've already signed up, great. If not, there's still time to sign up. I think you can go all the way up until the day of, I think, and they'll still probably take runners. But there are a lot of different races. So the marathon, which is a little over 26 miles, you can do a half marathon, which I think Cece's just going to go for the full marathon. No? Yes? I see you cracking up over
No.
there because it's true. Is that not?
No, I have friends who do that. I don't do that.
All right.
No.
Well, you'll cheer them on.
Yes.
But anyway, so there's the marathon, half marathon, 10K, 6K, and then I think there's even something for the little kids or something like that. I think they might have, but I think it's just basically 6K, 10K, half marathon, and then the full marathon. So the marathon, it says, is 26.2 miles, and the marathon was one of the original Olympic events. However, that measurement of how far it is, 26.2 miles, wasn't standardized until 1921. And that is because, if I remember correctly, the King of England at that time, or one of those royal family members, decided where they were going to be at the end of the race, and that's where the race ended, and that was going to be the measurement that now became 26.2 miles. So that's why that happened. So anyway, women's marathon was introduced in 1984, won by Joan, 2:24:52. The current record, so the men, 2 hours, 35 seconds. When I was growing up, a 4-minute mile was a big deal. Since then, the 4-minute mile has been shattered, and I'm sure that a 2-hour marathon will soon be shattered as well. And then the women, just a few more minutes over that 2-hour mark. So a lot of times, especially in elementary schools, students are presented with customary units and metric units. And a lot of times they have to convert between them. And we can see that we know that 1 kilometer is equal to 0.62 miles. So we will do the easier one first of the 10. And we simply see that there is a 0. So we're just going to move it over 1 place. So that is going to be 6.2 miles. So when Cece says, oh, I'm going to do a 10K, right? Because I did a 10K.
I'm gonna work on a 10K.
Also again this year.
Yeah.
So a 10K is only a little over 6 miles.
Only.
And when you do that, you're like, wow, that was pretty easy. You know what? I think I'm going to be doing a half marathon next. And then you'll do that. And all you're doing is just doubling that, right?
No.
So anyway, so we'll have 6 times 0.62 for our 6 kilometers, because that is one of the shorter races for the Bakersfield Marathon and other marathons as well, which is going to come out to be 3.72 miles. And that's just one instance, one example of how students have to go between customary and metric systems. That is today's Math in the News. We'll be back with more right after this.
Hello, I'm Ian.
And I'm Hugo.
Today we'll be showing you how to properly divide fractions.
Now, when dividing fractions, the most common method is the keep it, switch it, flip it method, where essentially you keep the first fraction perfectly fine and intact, you switch divisions to multiplication, and you make the last fraction become the reciprocal of itself. For example, 1/2, the reciprocal of 1/2 would be 2 over 1.
The reason why this works is when you put a number over 2, that helps you divide by 2, but if you flip it around, it helps you multiply by 2.
Let's use this knowledge on an example. We have written down 3/8 divided by 5/6. Now, with this method in mind, we bring it down, switch division to multiplication, and make the last fraction become the reciprocal of itself. Let's use this on a model. We can see that we have modeled 3/4 divided by 1/2. Now we're going to bring this down and merge them.
When you merge them, you just overlap the fractions. We can see here that it is, you bring it down and then it's the 4 parts from this fraction going up and down, and then side to side is the 1/2 from this fraction. We do it on both sides. We do it one over here and one over here. We still keep the same total amount shaded in. So this is 1/2 of it, and then this is the next, the 3/4. Then, since there's 4 pieces here, 1, 2, 3, 4, this whole entire thing is one group. So in that one group, we could count 4 over here, 1, 2, 3, 4. So that is 4 pieces, which is one whole. There are 2 extras, so we put that over the total number of pieces needed, which is 2 over 4. So the answer is 1 and 2 over 4, which is equivalent to 1 and 1/2.
Let's use another example. We can see that we have modeled 2/3 divided by 3/5. We're going to bring it down and merge them again.
We do the same problem here. We bring it down 1, 2, 3, 4, 5 for the fifths. Then we do the same thing over here, 1, 2, 3. Then we just overlap the 2 fractions, and then we have the same amounts shaded. When going side to side, we see 1, 2, 3 of the fifths. Then we see 1, 2 of the thirds. We count these all in one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this entire thing is one whole. We count the same pieces over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So then that is equivalent to one whole, and then we have one extra piece, which we put it over the denominator, which in this case is 9. So the answer is 1 and 1/9. I'm Ian.
And I'm Hugo.
Thank you for listening to our presentation today.
Another fantastic job right there by some kids talking math right there. We're going to go to the phones right now, and we have Parker, a 6th grade student from American Elementary. How are you today, Parker? And I think I heard you there, Parker. Are you there? All right, so it's kind of faint. Can you hear him, Cece, Parker?
Cannot.
I can hear a little bit. But what we're going to do is, Parker, if you can, maybe just speak a little louder or maybe more direct into the phone. We're going to take a look at the board right now, and I do believe this is the problem that you're working on, that you phoned in with, and you sent us the photo to our email. So is this the problem indeed that you're working on, Parker? Okay, so we're trying to get him back on, so we'll
Okay.
just wait just a quick moment.
Okay.
But do you, Braxton, remember when you were in 6th grade doing mean, median, mode, and stuff like that?
Yeah, I do.
What can you tell us about mean?
So the mean is going to be the the group of numbers that you have given in the problem, you're going to add them all up and then divide by the amount of numbers that you have.
Good. So that's the mean or the average.
Yes.
Okay. Median, do you remember what that is?
Median is just the number in between all of them.
Right. It's the number in the middle.
Yep.
And I tell students a lot of times when you're driving on a road in between the oncoming traffic and you, the thing in the middle is called the median because it's in the middle of the road.
Yep.
And what about mode? Do you remember what the mode is? M-O, most often.
Yeah, the most often.
There you
I
go,
do remember
right?
that. Yep.
Okay.
Yep.
So the number that shows up the most often, and in this one, it doesn't look like
Doesn't
there's
look
a
like we have
mode.
one.
It doesn't look like there is one.
And so then in that case, we would just write no mode. But we're going to see, so Parker, do we have Parker back on the line? All right, so what we're going to do is we're just kind of go through this problem, I guess.
Yeah.
Oh, we've got him. So Parker, are you there now,
Yeah.
Parker? All right, excellent. So we can hear you a lot better now. Parker, explain what you need to do with this problem.
I need to find the IQR, the
Interquartile?
the Q1 and Q3.
Ah, okay, very good. So we aren't doing our mean, median, and modes because they gave us the median. Mode, we had already discussed, we don't have one.
Right.
And mean, we could add them together and then divide. So that would be what we would do if we were going to do that. But you're telling me we need our Q1, our Q3, we need that interquartile range, correct?
Yes.
Are you doing an actual box and whisker, or you're just needing to find those couple of pieces?
I'm just trying to figure out how to do IQR.
Oh, okay. There we go. All right, so then let's go ahead and really quickly, first off, of course, we've got to put them in order, which is already done. That is the first thing that we need to do. Now, the reason that we do this type of work is normally we're talking about how numbers are distributed. So we might be talking about, say, like kids took a test and these are all of their scores. So we're kind of trying to analyze how those scores kind of fell, you know, in a range of how well students did and whatnot, right? So, so what do you know about a Q1? What does Q1 even stand for?
I don't really know.
So-
I wasn't here for the entire lesson because
Okay.
I was doing band.
Perfect. Well, I hope band was exciting, and we're going to learn about Q1. So Q1 simply means quartile 1, quarter, right? We hear the word quarter into it. So what do we know about a quartile or quarter?
It's a part of one of the sections.
Okay, good. And how much of a quarter is a dollar? How much of a dollar is a quarter?
1/4.
Right, so we're going to look for the first fourth of these numbers. So when I see this, we're going to say, okay, where is my, this is my middle. I need to find that first quarter, so I'm really looking for my half of that first half, right? Because if this is half, then I need my half. So where is my half of my first half? What number would that be?
57.
Right, so this is going to be my Q1 or my quartile 1. All right, what is going to be, so then I have my Q1, technically speaking, we could say this is Q2 because this ends my second quarter, but of course it's also the median, so we stick with median. So we have the first quartile or the first fourth of numbers, we have the second fourth of numbers, now we need our Q3, our third our third quarter of numbers, and what number is that going to be?
81.
Perfect, so this is my Q3. So I have Q1 is equal to 57. I have Q3 is equal to 81. And then we're looking for an IR, or otherwise known as our interquartile range, right? So this is our range from quarter 1 to quarter 3. Interquartile range. Okay, so what do we know about a range? Our range is usually what?
Our highest number minus our lowest number.
Exactly right. We're just saying what is the span of the number. So all we're going to do is we're going to do 81 minus 57, and what are we going to get here?
28, or not 28, 26.
So I'm going to go ahead and do this. My 11 minus 7 gives me 4. 7 minus 5 gives me 2, so we've got 24. So my interquartile range is 24. Cool?
Mm-hmm.
All right. And that's as
All
much
right,
as we
so
needed,
that
yeah?
helped you out, Parker?
Yes.
All right, good. Well, thanks for phoning in with that problem. And for phoning in with that problem, you've got yourself a pass to CALM. So congratulations on that. Hopefully you have an opportunity to go out there, see some of the animals. And always fascinating to see all of the different exhibits. A lot of new things are always going on at CALM. So Parker, we certainly do appreciate you phoning in and hope you have some time to go out and visit that right there. We'll be back with more right after this.
NASA's Artemis missions will establish the first long-term human presence on the lunar surface. Living and working on the lunar surface will require using resources that are already present there, like water ice, which can be used for life support and fuel. The Polar Resources Ice Mining Experiment 1, or Prime 1, will be deployed to the lunar South Pole by our commercial lunar lander partner, Intuitive Machines. Prime 1 is intended to drill for water on the lunar surface. Prime 1 is the combination of two instruments, a drill built by Honeybee Robotics called Trident, which stands for the Regolith Ice Drill for Exploring New Terrain, and the Mass Spectrometer Observing Lunar Operations, or MSOLO, which is a commercially available mass spectrometer from our industry partner Inficon that we have modified for operation in the harsh space environment. Trident will drill into the lunar surface, taking one small bite deeper into the soil at a time and bringing that sample up and depositing it on the lunar surface. MSOLO will then evaluate those samples as they arrive on the surface to identify and measure the composition of water and other volatiles emanating from the samples. The objective of Prime 1 is to inform NASA's plans for mining resources on the lunar surface, as well as mission operations for a future NASA lunar rover mission called Viper. So how will we extract water on the moon? The Prime 1 mission will set the foundation for future resource utilization on the moon, a key component for the success of upcoming Artemis missions, as well as expanding human exploration of our solar system.
Yes, robots have been helping humans in space for a long time. We've sent rovers to Mars, spacecraft to orbit other planets. Robots have even been helping astronauts on the International Space Station. One of the really cool things about robots is they can help humans do repetitive or even dangerous tasks. With Artemis, NASA is working to build a sustainable human presence on the moon, and robots will be an important part of that. They will help build new structures, perform inspections, gather data from previously unexplored areas, and perform science experiments to help us understand the environment. And now we're making even more advanced, intelligent, and agile robots. At NASA's Jet Propulsion Laboratory, we're working on a project called CADRE, short for Cooperative Autonomous Distributed Robotic Exploration, to demonstrate a new technology of cooperative multi-agent autonomy. CADRE is a network of shoebox-sized mobile robots that will coordinate amongst each other to accomplish a goal, such as exploring or mapping an area, without a human controller in the loop. This technology will change the way we think about missions in the future and unlock immense opportunities. They could explore areas that are not easily accessible for humans, like lava tubes or icy caves or subsurface oceans in search of water and other minerals. And it would be okay even if a robot doesn't make it back out, because it would have shared its data with the rest of the team. So do robots help humans in space? Yes, and at NASA, we're building a whole new fleet of robots that are going to help humans explore Moon, Mars, and beyond.
Always a lot of science involved with NASA and always a lot of science involved with math. Let's check it out right now.
All right, so hi, here we are with our last science of the season. And today we have Michelle from STEAM and Expanded Learning. Thank you for being here today.
It is a pleasure to be here today.
Yeah, so what are the kids going to be doing today?
Well, today we have an exciting challenge planned for the students to take part in. The students are actually today going to be we're playing around in the space of systems engineers and design engineers. And the activity itself is actually called assembly line. And we're going to start, of course, we'll be doing our design challenge today in a couple different chunks, different segments over the course of the show. But to start, we are going to begin with a little bit of reverse engineering.
All right.
And with some very fancy equipment. The cool thing about this project is it certainly is something that can be done at home. Really, all you need are a collection of ballpoint pens to do the project. And so, don't touch anything just yet, students, but I do want to give you a little bit of direction for this first reverse engineering piece, okay? So part one is this. Each of you should have your own plate for this first part because as you do this part, I want you to use that plate as a place to collect your pieces as you reverse engineer the pen. Does anybody think they know what I mean by reverse engineer the ballpoint pen? Right here, go ahead.
Take it apart and then put it back together?
Yes. We're going to, step one will be to take the pen apart, okay? Take the pen apart and put all the parts on your plate. And that's as much as I want you to do right now. And if by some, if something happens and parts actually get broken as we take your pen apart, it's fine. I have lots of extra pens for the rest of our activity. So, part one, and I'm not going to give you any directions around how to take that pen apart. I want you to do your own problem solving for that. So my directions really very simply are this. Take the, reverse engineer the pen, take it apart, and just put all the parts on your plate. Are you ready?
Yeah.
Go.
All right. Good.
And you'll know that you have your pen completely reverse engineered when you have 6 parts on your plate. 6 parts on the plate. And if you need to, this part right here can be used to help kind of serve as a poker or a pusher to completely reverse engineer the pen. Do we need an extra plate over here? Are you good? Okay.
How do you take it? Ratchet or whatever it's called.
Oh, this is
So, neat. There you go. Well, check this out. So if you, I notice that some of you are stuck at this part, right?
Yeah.
And this part does come out. So think about this. We can use this as a secondary tool to help us reverse engineer our pen. And I noticed some people trying from this end to try to push it out that way, potentially. I had some people using that end to push it out that way. I've seen some people going from the other direction to try to push. Because how many pieces are left inside once you get to the lid part?
2.
Yeah, there's 2 pieces inside there. And they come out.
I've got a couple people have done it.
All right, very good. Excellent, excellent. Excellent, we've almost achieved success. Excellent.
Well, I got one.
All right.
Alright, well, so far we have all these kids reverse engineering their pens, so when we get back, we'll see the rest of our challenge, right?
Yeah.
Okay, back to you, Mike.
All right, thanks for that, Sam and Michelle. And we were just talking about that. A lot different then, because I remember a long time ago, like you were saying that you used to take them apart in class, and we all did.
Yeah.
But the big pens with the clear tube, it was just like, all right, you just take the top, poke it, and the whole thing came, and then that was it. So minimal parts back then. All right, you ready to finally do some work?
Yeah, I am.
All right, over to the board.
All right.
So we have a rectangle that measures 13 by 11.
Got it.
I want you to put squares in there, and I want you to fill it in with the fewest number of squares possible so that the entire thing is covered.
Okay. So like, are you saying the grids right here, like
Right.
all the grids are?
So what you have to, so let's say you wanted to make a 4 by 4 square. That would be 1 square, but it would only cover 16 altogether.
Oh, yeah, 4 by 4. Okay, yeah.
Okay, I see what
So
you're
we want the fewest squares.
You want the fewest number of squares possible.
Okay.
So, Can I just say this is 1 square and then we're just 1 square and we're
Well,
we're all good?
13 by 11 is not a square.
Oh yeah, you're right. You're
Easy
right.
there, wise guy. I'm
that
not giving it to you
you're
that
right,
easy.
You're right. You're right. So.
First thought is what?
I was thinking just cutting it by 2 and then just making it an 11 by 11 square.
That was kind of my first thought too. So if we do that, go ahead and do that. You know what? Let's change colors
The
if I
color,
can.
yeah. Got it.
Okay, so go ahead and do that.
So
Okay, so that
that's
gives us
1 square.
All right.
So
then-
label that 11 by 11.
Okay, so like right here, like that.
No, the larger one.
Oh yeah, yep. Because that already is 11, huh?
Right.
So
inside the large one.
right here.
So
This
just
is
in,
now
inside. Just go inside 11 by
Got it.
11.
Okay.
Okay.
So that's 1 square. Mm-hmm. Is that just the answer?
Okay, so no, because
Well,
we got it.
you
We've
have
got
to
to break
cover everything
this
else
one.
up.
out.
Okay. Okay, I'm understanding.
Yep.
now. So then I would imagine we just have to do that,
Yeah.
that, but then we'd have to go like this and that.
Okay, so then we've got 1, 2, 3, 4, 5, 6, 7, 8. So that's 8. Okay, so let's see. So we know that we can do it in 8. So
Can do it in 8.
So let's erase and see if we can do
Got
it in.
Because it can be done in fewer.
Okay.
Do you know, are you allowed to give us that number?
He's not going to.
Oh.
You look at that face. He's not.
Yeah, he's too mean.
I could give it to you, but I'm
yeah.
not right yet.
Yeah. Okay. All right.
Okay.
So it's less than 8.
So.
Okay. So starting with an 11 by 11 yielded 8. Okay. So what do we want to do instead?
Do you want to cut it in half?
I'm kind of wondering that, yeah, if we go as close to half as we can, maybe.
Okay, so right here,
Sure. What does that do for us?
that becomes 5 by 7. Wait, no, that's.
Yeah, if you do a 7 by 7 and a 6 by 6,
So,
start with that. A 7 by 7 and a 6 by 6,
7
cutting
by
13
7.
in half.
So 1, 2, 3, 4, 5, 6, 7.
So right here.
Yeah. Okay, except we can't go all the way through because that's not.
A square.
So it has to stop. So it has to stop here. Okay, so that's a 7 by 7.
Then we can go up here.
Yeah.
That becomes a 6 by 6.
Okay.
This is a 5 by 6. So,
So
sorry.
let's see. So 1, 2, 3, 4, 5. So if we do, let's get rid of this line too. Maybe that'll help.
Got it.
Maybe. I don't know. Maybe. Okay, so 1, 2, 3, 4.
We can make a 4 by 4 right
Okay,
there.
I like that idea.
Okay.
Let's try that.
So that's a 4 by 4.
Oh, this is looking ugly.
yeah.
Okay.
But you're on your
Okay,
way, label
okay.
that up.
Okay, so that's a 4 by 4. Okay, good.
Got it.
Okay.
What's the next
Ooh,
biggest
wait.
one you could make?
1, 2, 3, 4, 5. 1, 2, 3, 4. We can do
We
that.
can do this.
I like that.
That becomes 5 by 5.
Okay.
And now that
Hey.
is 1 by
Okay, I
1,
like it. I like it.
4 by 4.
Okay, so 1, 2, 3, 4, 5, 6.
Is that it?
6 is the correct answer.
Yeah.
Okay,
Nice.
hey, there we go.
So it just took a little bit of time, and a lot of students do what you did. You're like, all right, it's a logical thing. Try the 11 by 11.
Yeah.
And a lot of kids think, well, I found the biggest one, and whatever else comes about it, that's it.
Yeah.
They turn it in, they go, I got 8.
Yeah.
But you didn't find the fewest.
Yeah.
Nope.
So try it again, right? And then you just have to think about it, and you did, and it only took you 2 tries to get that done right there.
Yep.
So nicely done. So I can see that you liked the squares. So perhaps we'll do some triangle work a little bit later on.
Okay.
But we'll do that right after.
Yay.
Mining and geological engineers design mines above and below the ground to remove minerals and metals used by manufacturing industries and utilities. They design methods to transport mined materials to processing plants and monitor operations for safety and efficiency. Critically, they also develop solutions to manage mines' environmental impacts, including land reclamation and mitigating water and air pollution. 3 types of engineers typically work in mining. Geological engineers search for mineral deposits and evaluate possible sites, then plan how to extract the metals or minerals safely and efficiently. Mining engineers specialize in mining a particular mineral or metal, such as coal or gold. Some develop new equipment or direct processing operations. Mining safety engineers ensure that workers are safe and mines meet safety regulations. They monitor air quality and inspect mines and equipment for possible hazards. Mining engineers often work at mining operations in remote locations, although some work in sand and gravel operations near cities or at mining firms or consulting companies in large urban areas. Most work full-time with additional hours when posted at mining sites. A bachelor's degree from an accredited engineering program is required to become a mining or geological engineer. Relatively few schools offer the program. Licensure is not required for entry-level jobs, but many experienced engineers obtain licensure for more advanced positions.
Whether working around the globe at mines and drilling locations or in labs analyzing data, geological and petroleum technicians help scientists identify locations that indicate the presence of potential resources such as oil and gas, minerals, or metallic ores. In the field, geological and petroleum technicians use sophisticated equipment such as seismic instruments to gather geological data. Under the supervision of geologists and engineers, they gather rock and soil samples and work with environmental scientists and technicians to monitor the environmental impact of drilling and mining. In laboratories, these technicians analyze samples for evidence of hydrocarbons, useful metals, or precious gemstones. They analyze data, produce maps, and write reports detailing a site's potential for further exploration or explaining a current site's productivity. Most geological and petroleum technicians work standard full-time business hours, except when they're working in the field. Field work is conducted outdoors in all types of weather, sometimes for weeks at a time, and at times in remote locations. Many technicians work in mining-related operations, oil and gas extraction, and for engineering services. Jobs in this field typically require an associate's degree or 2 years of college courses in applied science or science-related technology. Some highly technical jobs require a bachelor's degree.
And right now we have an opportunity to head back downstairs. We'll check out how they're doing with their reverse engineering. Sam, what's up now?
Okay, so the kids have engineered their pens and have now put them back together.
And reassembled.
Yes.
During the break.
So
yes.
what's up next?
Well, next we are going to now go into the assembly line part of our challenge, of today's challenge, which means this, students. So in a second, I'm going to say go, and the task at that point will be to take the pen apart. Don't do anything yet, but when I say go, I want you to take the pens apart again. And this time, though, instead of collecting all of your own parts on your individual plate, I want you to collectively, as teams, sort the items so that you have 6 plates, because how many parts are there to the pen?
6.
Yes, through our reverse engineering, we figured out that there are 6 parts to the pen. So 1 type of part per plate, and once I see that, then we'll move into the assembly line part, all right? So go ahead and take your pen apart and let's sort the parts onto the plates. Excellent.
I have an idea. We're gonna bring all the bottoms in here, and then we'll have all the springs in this one, and then we'll have all the inks in yours, and then all the clear parts and the girl with the purple watch, and then the push button is gonna be with her, and then the ratchet is gonna be with her. Guys, can you please? You guys, okay, I'm gonna have all your guys give me.
There you go. Awesome.
Who's gonna be
excellent?
Here, wait, Mark, give me this one.
Right on. I should see all the springs on a plate, all the caps on a plate.
Springs.
All the ratchets on a plate. There we go. We're almost ready.
I have 5.
Almost. Excellent. We're ready on this side. Almost there. Over here. All right.
We're done.
Great.
Hold on, sir. I was holding the 6th pen.
Uh-oh. All right. So while we're taking this last pen apart, because we have one less person over here on this side, so these guys are going to have to be extra efficient. But we'll declare the winner based on time. So And I already heard some conversation about this in the groups. But your mission, in just a moment, is going to be to have a conversation in your groups real quick about what that assembly line strategy is going to look like. And I'm going to give you 30 seconds to have this conversation and decide what order you want to put those parts in and who's going to do each part. Ready? Go. Okay. I'm timing. I'm timing. I'm timing.
Okay, perfect. It's good. Okay, we pass one down each. We should assemble part of it so like the head goes first and then the second.
All right. Time's up.
Oh my gosh, that's really quick.
Are we ready?
Okay, wait.
Yeah. All right.
Got my timer.
Have a seat. Now, the real fun is about to begin. So your mission is this. And it's up to you as a team whether you start on this end or that end. But somehow you're going to work down the table to reassemble all 6 pens. And Miss Sam is going to be pushing the timer to start timing how we do once I say go. Ready? Question real quick?
Does the winner get anything?
Yes!
Get a high five.
You get the satisfaction and Chick-fil-A brownies and lemonade.
Bragging rights.
Oh my God! And bragging rights. You're just being awesome. So are you ready?
Hey, here we go.
Ready? Set. Go. Bill, you reassemble those pens.
Wait, where are we passing it down?
Pass it down so that everyone gets one. Pass down the springs.
Oh, that's it.
Pass down the springs.
Put your part in.
I already got one. Go.
Put your part in.
Pass down the ink. Pass down the ink.
Pass it down.
Okay, take one and pass it down.
Use my first one. I already did one, two. Okay, give me a spring.
I need the ratchet.
Avian, you have to do one. Avian, you have to do one.
I need the ratchet anyway.
Avian, I repeat, you have to do one. Here, guys. Another one. I did 3.
I need 2.
Go. I think we're already done. No, we assembled.
Do they work?
No, we assembled. I think we're already done. Yeah, we're done.
You guys are already done.
Test them.
We're done. Yep,
Test them.
Done.
All 6? All 6? Let me see if they work.
All 6 work.
All right, we got 1,
Yes, guys.
2, 3, 4, 5, and 6. Excellent. Let's see how this group over here is doing.
We're doing so good.
Yeah.
All right, so they've done this once. I believe they're going to do it one more time and see if they're going to be it faster. And then if we have time at the end, we're going to see who can do it the fastest. One person, so. All right, back to you, Mike.
All right, thanks for that, Sam. Those guys were working at a furious pace down there, that one team. We'll be back with more right after this.
Welcome to Cal State San Marcos, a powerhouse of higher education with a mission of student success. As a proud federally designated minority-serving institution, HSI and ANAPISI, over half of our students are first-generation trailblazers. And we serve the highest number of military-affiliated students per capita in the entire CSU. As the #1 ranked university in the nation in social mobility, we work with partners to send the message to every young person. Yes, you can go to college.
The Alliance program opens doors for students who might not otherwise be on the track for college. Exposure is huge. It provides opportunities for students to see that they can go to college. If they can dream it, they can do it, and see that college is for them.
The most important thing is showing up. And I think they've done that. Making sure that those who need the step further is important. And we have one goal in mind, to make sure we have a successful community for everyone.
Faculty-student mentorship is deepened through undergraduate research, scholarship, and creative activities. As a first-generation undergraduate, Dr. Raymond Malfavon Borja was part of the Center for Training, Research, and Educational Excellence at CSUSM. He went on to get his PhD, and now, in a full circle moment, he dedicates his time to training and mentoring underrepresented students in the sciences at CSUSM.
It means the world to me to be able to work with our students here, the chance to guide them, mentor them. I take that really seriously. We let them know that we were in similar footsteps to their own, especially myself, right? I was in their seats as an undergrad here, and now I'm on the other side of it, but we share with them that I was first generation, I was a low-income student. What's really special is in our center, everyone is first generation. We all happen to be this collection of first generation academic professionals, and I think that's one great strength with connecting with students and helping them to know that if they did it, we can do it too.
Our students learn in and out of the classroom, developing practical skills that set them apart. That includes those who are eager to strike out on their own and make a difference while doing it. Sophia Lombardi is a recent graduate who started her own sustainable swimsuit business as an undergraduate. As a member of the CSUSM Entrepreneurship Society, she won the university's annual Quick Pitch competition to fund her company and bring her vision to life.
The Quick Pitch competition really opened a lot of doors. Specifically, I was able to get introduced to the social enterprise program, which was really cool because both the students participating and myself were able to get real-world experience.
Sophia had the opportunity to lead and collaborate with fellow students, ensuring her business met its demands while maintaining her vision of sustainability.
It's so important for fashion brands to really incorporate sustainability. I decided I wouldn't be a part of that, and I knew it was my responsibility that I had, and I wasn't just going to ignore it.
With a focus on addressing critical workforce needs, our engineering program was established in 2019. Mariposa Rodarte Iman is a first-generation student blazing a trail in a field historically underrepresented in terms of diversity. Our dedicated engineering faculty are empowering students like Mariposa to raise their voices and shine brightly.
It kind of prepares me for the real field that is going to be expected, but to not be afraid and just to only push harder.
Viasat supported the founding of engineering at Cal State San Marcos because we believe in the transformational force STEM fields can have on social mobility. And we're not done yet. We continue to champion and invite community partners to join us in making an investment in Cal State San Marcos and its amazing students. The future integrated science and engineering building will have a transformational impact on our region.
Leading at the intersection of innovation and social justice, Cal State San Marcos magnifies student opportunity, transforming lives and communities.
Being one of the top universities in the nation on social mobility comes with tremendous responsibility. We owe it to our students to double down and make sure that we are serving them and that we get them to the graduation finish line.
Leading with care, fostering academic excellence, and innovating and adapting to the needs of the future. We stand as a beacon of promise and possibility.
That's the power of you. That's the power of us. That's the power of CSUSM.
Another great school in the CSU system. We're going to check in for one last time with our kids downstairs and check out this science. Sam, what do you got?
Okay, so Michelle, you have some questions for the kids, right?
Yes, I do. If you noticed, when the students were doing their assembly line work, we had some really different strategies on one side of the room versus the other side of the room. So I'd like to hear from a couple of the students about if you were to do this again, what would you do differently? As well as go ahead and share with us a little bit too about, what do you think went well for your team as well? We'll start here and then work our way down.
Yeah, so we wanted to do like double of everything to make it more efficient. So like holding double pens, inserting double inks, like doing double of everything. So make it more efficient and quick.
Go douche douche.
Yeah.
All right, got it. How about you?
So we split up all the parts of the pen. Like us three did like 2 or 3 parts of the pen, and they did 2 or 3 parts of the pen, and then we combined it after.
Did you find that to be efficient?
I guess.
Okay. Yeah, you managed to put all the pins back together. Right? Okay, how about down here?
For our strategy, we wouldn't change anything because we're just good like that.
So, but what do you think was key though?
Well, I think what was key was splitting it up. So half
half did half, and then the other half did half.
Okay.
Of the pen.
Did you want to add to that?
I do think that splitting us up made us more efficient, but I also think the order made us more efficient, because if like we had the spring over here, the cap over there, we'd be like, wait, where's the spring? And we put it in like, we thought, like we looked at our picture we have here, and we put it in like a system, like in order, so we would go faster.
Excellent. All right, how about over here? What went well and what are some system improvements that you would make? Start down here.
So something that went well was that we were able to pass down the each piece like quick, but something that didn't go well was like the strategy of passing down the pieces wasn't like that good. It could have been better if we like had a piece and we put it in and we passed down each time we added something to it.
Okay, you want to add to that?
I would change instead each person passes the piece down to the next and they put those two parts together and then pass it down to the next so that one pen can get assembled at a time. Because to me that's a real assembly line.
Okay, excellent.
Basically what
Add
I
on to that?
said.
Okay.
But we got two of the pens assembled, so that's good.
Yeah, you were getting that. Yes, go ahead, Cher.
Maybe one of us can grab all the essentials and just quickly pass it down, running through the table, and another person can just do the same thing. And in the meantime, they can just be assembling it.
Excellent.
All right.
Lots of good thinking, right?
Yes, yes.
I think we're ready to go open up our own pen factory.
All right. So
Design and create our own
think
pen
so.
factory.
All right. So, well, thank you so much for
Yeah,
being
thank you.
here. It was a great time. And Mike, it's back to you.
All right, thanks for that, Sam and Michelle. And upstairs right now we have Braxton, a senior at Frontier High School, ready to work on another problem. So Braxton, the triangle that you are closest to,
Yep.
I want you guys to figure out how many triangles are there on the one on the right.
On the right?
Yes.
There's 4.
4?
Yep.
There's more.
More? Oh, there is more. You're right. So there's 1, 2, 3, 4, 5, 6.
There you go, 6.
Yep.
All right.
Yep.
So there are 6. And what I want you to do is next to that, I'm going to give you a formula that you can figure it out instead of trying to count them all, because if you had one with a lot of lines in between it could get confusing. So here we go. Here's the formula. N, then open parentheses, n minus 1,
n minus 1,
close parentheses, draw a fraction bar underneath it, divided by 2, so 2.
Got it.
So n is the number of lines that you've got. How many lines are there?
Are we inside the triangle?
The whole thing.
So 1, 2, 3, 4, 5.
So, well, 4 vertical lines.
Oh, 4 vertical lines. Okay.
So we have 4 is n, and then 4 minus 1 is 3, so 4 times 3 is 12.
12 divided by 2 is 6.
That's how we get to 6.
Got it.
Now, see if you can figure out how many triangles are where Cece is. Now we've got some horizontal lines.
Okay, now that's not fair, because we were trying to do that earlier, and you told us that's not what
Because
we were
I don't
supposed
want
to
you
do.
getting ahead of the game. See, because then you'd be like, oh yeah, we already got it solved, right?
Okay.
All right.
Yeah.
So
You've got 3 minutes.
Okay.
Do we count the vertical lines now too?
I don't know.
Okay, that sounds good.
They're in there. Now, if you take the formula I gave you, because everything's the same except for 2 horizontal lines now.
Yeah.
So see if you can
okay.
incorporate that into the formula.
So what if we use the formula just for this section? So
Okay, I see
Okay,
what you're saying.
okay.
Got it. So we'll go, it's the same thing, it's just going to be 6.
Okay, good.
And then
we can do what? We'll change colors, and then we can do what?
the same thing right here, but
Okay.
we'll just ignore this line
Okay.
and then add 6 at the end.
Okay, I think so too.
So wouldn't it just be 6 plus 6?
I think so.
So then-
I'm thinking I'm going that way right now
I've seen
too.
a
Okay,
pattern.
okay. Let's go ahead and try
So
it.
we'll go the 4 lines, so it'd be 4, and then 4 minus 1 all over 2, and we did it on this side,
Yeah,
so we know that's equal to
6,
6,
okay.
and then we add those 2 together.
Okay, so
we get 12.
Okay, and then let's change it to color again, and then
We'll go the same thing.
okay, I
So
think
then just
I like
add-
it.
And then add 12 at the end. So wouldn't it just be 18? Would it be that?
Well, it would be 18. 18 is correct.
Okay.
But what I want you to do is rewrite the original formula again in the middle of the whole board with the n's.
So
Okay,
n.
Here, let me change the
Okay.
color. Go ahead.
So n minus 1 all over 2.
Okay, now it's the same thing, but let's imagine instead of I had 2 other lines in there, imagine I had 75 other lines and that thing just kept getting bigger and bigger and bigger. You wouldn't want to keep doing that, right?
Got it. Got it.
So all you have to do is how many more horizontal lines are in that as opposed to the first one?
Can you reset?
Okay, so I think what you're saying is there's 2.
Right. So put a
Okay.
2 in front of the n.
So 2n.
Right.
Okay.
Now
solve it.
Right.
So
2
2
times
times 4 is 8. And then 4 minus 1 is 3. 8 times 3 is 24. Divided by 2 is 12.
How many horizontal lines are there altogether, though? Because there were 2 new ones.
There
but how
are
many
3. There are 3. So it'd be
Is that what you
3n. So it'd be 3 times 4 is 12. Times 3 is 36. Divided by 2 is 8.
Now you
got
it.
Okay,
All right.
okay,
See,
okay.
so all you have to do is when you get a problem, because you're going to get problems like this.
Yep.
Right?
Yep.
And all you have to do is go, all right, I kind of remember that.
Okay.
And then figure out the number of horizontal lines, and you just
Can I make just one note? So we were going to change that to a 3, right?
Right. Yeah.
1, 2, 3.
because
so
number 3.
we have the original one was a 1, so we kind of don't want to ignore the horizontal
Yeah,
there, so that we have our formula.
So how many
that's,
more did you have?
Because
Yeah,
there's
yeah,
the
yeah.
invisible one right
Yeah,
here.
so there's our formula
Got
is
it.
there.
Did nicely on
Horizontal
that.
times.
Come on over here. So we've got a quick minute here. So I've got a couple of bonus questions for you today, since this is the last show of the day. How many times can you subtract the number 5 from 25?
5.
Once, because then it's 20.
Got it.
All right. See, there are going to be questions like
Okay,
this. All right,
okay.
you ready for another one?
Yeah.
All right. That was going to take a little bit of time. All right. How could you give someone $63 using 6 bills without using any $1 bills? You want to give somebody $63,
$63.
but you're not using any $1 bills.
You can't.
Well, you can.
Can you use
What
quarters?
Can you
bills
use change?
are there?
There's a 1, but we can't use that.
Right.
There's a 2. There's a 5.
10s and 20s.
10s
right?
and 20s.
Now,
So
the 2s you don't usually use,
we
right?
don't usually use those.
So we want $63. So how many
63.
20s should we use?
We should use 3 20s.
Okay.
No, we should use 2 20s.
Well, let's use 3.
Oh, okay, we'll use 3. So that's 60 right there.
But we can't, because then
can't.
you can't use 3
Yeah,
of
'cause then
anything, so
that's-
you're going to use 2.
So we're going
there's
to use
40.
2. That's 40. Then we can do a 10. That's 50. Then we can do a 5.
But you can only use 6 bills.
Oh, yeah.
So
Okay.
you're going to use...
So we're going to use, okay, let's try this
You
more
forgot
time.
the $50 bill.
Yeah, okay, so we do have a 50. So
Okay.
we have 50 right now.
And a 5.
And a 5, that's 55.
Okay.
And now we need 8.
So you use
So
4
we do
$2
4
bills.
$2
There you
bills.
go.
Got
Nicely
it.
done. Did you learn a little something today?
Yep.
You are now an ambassador for us. Did you have fun today?
I did.
Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.